So welcome again, everybody, and it is my esteemed pleasure to introduce our keynote for today, right on time, our opening speaker, Dr. David Wiley, who I had the pleasure of meeting at Rollins College just a few weeks ago. Dr. David Wiley is an associate professor and academic affairs fellow for AI education at Marshall University, where he teaches courses in entrepreneurship and management information systems. His work, spanning teaching, research, and consulting, sits at the intersection of generative AI, open education, entrepreneurship, instructional design, and student success. A recognized leader in innovation in education, Dr. Wiley is also one of the founding figures of the open educational resources movement, helping to shape the future of accessible, high-impact learning. Today, for TOPkit 2026, he will present a collaboration on OER, AI, and instructional design in a time of continuous transformation. So it is my pleasure to introduce Dr. David Wiley for our keynote session. And David, are you able to hear? I'm not sure that we can hear you.
Are you able to hear me?
Yes, we can.
Oh,
Perfect.
sorry about that.
Yeah, perfect.
I was just monologuing along here. No, I was saying that I'm grateful for the invitation and the opportunity to speak with you, and that even as recently as a week ago, I thought I knew what I was going to say today. And in the last couple of days, I've completely changed up everything that I'm going to share. And so you might get some ideas that are half-baked. So kind of caveat emptor, I guess, as far as that goes. But I hope I can still kind of embody the spirit of provocation that Charlotte and the others who asked me to speak today intended for me to. So let me share my screen. All right, is everybody seeing my screen? Charlotte, can you give me a thumbs up? Yay, okay. So I'm going to mention OER, but the further I got into this, the less and less of a role OER played. So I pulled it out of the title. But, well, let's just jump in and see where we go. I do not have, let me see. I don't have the chat open, but if you want to be throwing things in the chat, I hope that there's going to be plenty of time for us to have some conversation when we get to the end. So a few words of prelude about, as particularly from an instructional designer's point of view, the primary purpose of education. Now, in his biography of Isaac Newton, Stukely recounts this conversation that they had, sitting out in the garden, drinking some tea. He says, he recounts here, amidst other discourse, he, Isaac Newton, told me he was just in the same situation as when formerly the notion of gravitation came into his mind, and it was occasioned by the fall of an apple as he sat in a contemplative mood. I've always wondered if this was apocryphal, and so I went to try to find the source for this story, and apparently this is the source of us imagining that Newton, kind of came up with these fundamental ideas of gravity by seeing an apple fall. And it's made me wonder a little bit about what would it be like to learn about gravity the way that Isaac Newton did. So, imagine a course, Physics 151, Fundamentals of Gravity. The course description reads as follows. The prerequisites are you need a Newton-like background in mathematics and physics, you need a shady apple tree, and you need approximately 3 to 5 years because you're going to sit under that tree. Eventually, an apple's going to fall. It's going to cause some thought to go off in your mind, and then you're going to spend the next several years kind of deriving the fundamentals of gravity from that inspiration that you received under the apple tree. Now, no one would want to take a course like this, I assume, even though Isaac Newton might himself give a testimonial, this worked for me. So I want to make the claim here that the primary purpose of education is to increase the efficiency of learning. We're certainly able to learn outside of educational settings. Isaac Newton did it. He learned about gravity just sitting under that tree and thinking his thoughts. But it took him quite a while and quite a lot of effort. And when I think about education, I think about this subject matter expertise and instructional design expertise and how we bring those together as part of the educational enterprise. And if we think about a 2x2 where we have subject matter expertise being high or low and instructional design expertise being high or low. In a case where you might have a SME who knows very little about instructional design might be able to accurately convey information, but because they're the SME, but students might struggle to understand and remember and apply it later on. Contrawise, an instructional designer who knows all the instructional design things, but doesn't know much at all about the subject matter, might be able to help students thoroughly learn and remember, but the representations of the domain or the discipline that students learn and remember might not be accurate. So where we really want to be working is in this upper quadrant, right, where we have high subject matter expertise paired with high instructional design expertise, so that students' efforts toward learning turn into learning with maximum efficiency. Now, I'm not saying here that we want to reduce or eliminate productive struggle, which has become such a conversation topic in the context of AI. But what I am suggesting is that the reason that we get together for this educational enterprise is to try to either reduce or eliminate the unproductive struggle or the counterproductive struggle. I want you to do the struggling you need to do to learn the things you need to learn, but I don't want to see you off on side quests that are going to distract you for weeks or months or years that aren't actually adding to the thing that you're trying to learn. So we go from Isaac Newton seeing an apple fall, years of work, and we have some kind of understanding of gravity. And now today, I can pick up a book, and if I have the proper background, I can learn the fundamentals of gravity in a weekend. Over the course of just a couple of year degree in physics, I can go from simple machines all the way up through quantum mechanics very efficiently because I'm supported in that process by educators, people with subject matter expertise and instructional design expertise coming together with that. So again, I think what we're trying to do is we're trying to help students learn not with shortcuts, not undercutting productive struggle, but trying to keep the struggle focused in the productive domain so that students aren't struggling unproductively or counterproductively. It's really about helping. It's about assisting and increasing the efficiency of learning. For my money, kind of the single most important piece of this process is practice with feedback. I'm going to show you just 5 or 6 seconds of a video clip. This is a clip that I shot with my son, John, a number of years ago. He'd be mortified if he knew that I was still showing it because he is so much younger in this clip than he was. But I just want to, well, maybe I won't even show you the clip because I think I can describe it. So John has a wadded up piece of paper in his hand, and he's going to throw it into this basket that you see at the end of the hallway. And he's doing it with his eyes closed. And over the course of the video, he practices in kind of 3 formats of feedback. First time, he practices without any feedback at all. So he stands there with his eyes closed. I've got a number of these wadded up paper balls in my hands. And he throws with his eyes closed, and I hand him another, and he throws again, and he throws, and he throws, and he throws without ever looking, and without me ever giving him any feedback on how he's doing. And we have a brief discussion about how much practice without feedback would it take for him to master throwing the paper balls into this little bin. And the answer turns out being that you could practice infinitely and never master that. With your eyes closed, you don't know, are you too far, too short, too left, too right? You can't see because your eyes are closed. And so without feedback, the practice actually becomes unhelpful. So then we do a second session where I give him delayed feedback. So he throws the first paper ball and I make a note. He throws the second, he throws the third. And then before he throws the fourth paper ball, I give him feedback on how his first throw went. The first throw that you gave 3 throws ago was to the left. And then before the fifth throw, oh, your next throw 3 throws ago was a little short. And we do that, and he confides that receiving that delayed feedback is also not particularly helpful because by the time he receives the feedback, he can't really remember what he had done. And then we do practice with immediate feedback. So still his eyes are closed, he throws, and immediately after the throw, I say, that was a little to the left, that was a little short. And within a couple of throws, he manages to put one in the can when he's getting immediate feedback. And this is actually a really fun exercise to do when you've got people all in a room together, to have someone come up and do it and kind of watch, particularly the delayed feedback, watching them try to process, what did I do 3 throws ago? It was too far to the left. And this is the kind of feedback that we typically give our students, right? We ask them to do an assignment, and then we've got this stack of essays, and it takes us a while to grade it and get it back to them. And by the time we've gotten it back to them, they've gone on and they've done 2 or 3 other things. Or they're doing some math homework and they're sitting there and they just worked their 11th problem out. They have no idea, are they getting it right? Are they getting it wrong? They're just practicing with no feedback at all. And immediate feedback turns out to be so critically important, no matter what the domain is and what the kind of practice that we're doing. Now, there's an opportunity here for us to leverage technology, which we've been using for a long time, right? It's true that we can't be with every student every time they practice, but we can use technology to provide them with immediate feedback. And it turns out that when we do that, it's actually really very effective. This now kind of famous study by Ken Kadinger and his colleagues at Carnegie Mellon look at the relationship between what they call the doer effect here, where students are engaging in interactive practice that provides immediate feedback, the relationship between engaging in that kind of task and student learning. So they say here that the doer effect is an association between the number of online interactive practice activities that students do and their learning outcomes. It's not only statistically reliable, but has much higher positive effects than engaging with other kinds of learning resources like watching a video or reading a text. And they indicate here that looking at across 4 different courses, over 12,000 students, they see that the learning effect of doing is about 6 times greater than that of reading or of watching video. And it's not just that they're doing, but as you get into the paper, you'll see that students are doing something, but they're also receiving immediate feedback. Immediate feedback really is a key here. Now, if you've ever authored an online course and you wanted to provide feedback on every question that students would interact with, whether it was formative or summative or whatnot, that in some disciplines we can generate feedback in real time. In a computational discipline like math or physics or music theory, we can generate questions, we can look at students' responses, and we can generate feedback to them that's responsive to the particular ways that they're struggling. But in other disciplines, all the feedback that we want to give, we have to write out by hand, and we have to write it all out ahead of time because we're going to package it up and put it in the LMS. And obviously that process of having to write every individual piece of feedback by hand ahead of time limits the amount of feedback that we can provide, and it limits how responsive that feedback can be to the things that students are struggling with. Now, in the past, if you've heard me in the last year or so, or read anything that I've written during that time, you've probably heard me talk about what I'm calling generative OER, for lack of a better term, because I don't know how else to describe the combination of generative AI and OER. Generative OER seems like an okay name. But generative OER are not designed to be used directly for teaching, learning, or research. I think about these as being the things that we create to use as input into a generative AI system. Context, prompts, and model weights. And let me just say a word about open context, and then we're going to hear from somebody else about it. open context can look a little like traditional OER. It's words on a page, it's explaining or defining, but it's not material that we develop to give to students. It's material that we develop to give to a large language model so that as it interacts with students, its responses can be accurate and it won't hallucinate and say things that are ridiculous. Now, I've been talking about this for a while, but earlier this week, maybe last week, sometime recently, Andrej Karpathy, who is far and away my favorite person to listen to and read and watch and study on generative AI, said something similar. Now, Andrej was the director of AI at Tesla. He wrote all the early versions of their autopilot, or was responsible for it. And then he was the co-founder at OpenAI, who of course make the ChatGPT family of models. But in 2024, he left OpenAI and started pursuing his one true obsession full time, which is teaching people about generative AI and specifically how to design and train and build AI models. And I want to just show you two things here quickly. The first is a project that he's done called MicroGPT. And MicroGPT is in 200 lines of code, so it's not a lot of code, but it is a full generative pre-trained transformer. You can train your own large language model using just these 200 lines of code. And he has some explanation of how it works here. This is his probably fourth attempt. Before this one, he had one called Nano GPT, and he had another one called Make More. But he's just obsessed with trying to teach people how to make and how to understand GPTs. And this project is super fun. And it's also the kind of thing where even if you don't understand any Python, you can copy a couple of lines and paste it into, Claude or Gemini or ChatGPT and say, what is this doing? And in a relatively brief conversation, because there's only 200 lines here, you can actually start to wrap your head around how these things work. Now, recently, as I said, Andrej was on a podcast, on this No Priors podcast, talking about, and he's asked a question about MicroGPT and what he's trying to do with it. And something that he said just really struck me. So I want to share about 3 minutes of this interview with you. And when I shared my Zoom, I made sure to click share sound. So Charlotte, if you'll give me the thumbs up if you can hear this audio when it begins, I'd appreciate it.
Nice. And it was interesting to me, like normally before, like maybe a year ago or more, if I had come up with MicroGPT, I would be tempted to basically explain to people. Like I have a video, like stepping through it or something like that. And I actually tried to make that video a little bit. And I tried to make like a little guide to it and so on. Mm-hmm. I kind of realized that this is not really adding too much because it's already so simple that it's 200 lines that anyone could ask their agent to explain it in various ways. And the agents, like, I'm not explaining it to people anymore. I'm explaining it to agents. If you can explain it to agents, then agents can be the router and they can actually target it to the human in their language with infinite, patience mm-hmm. and just at their capability and so on.
Right. If I don't understand this particular function, I can ask the agent to explain it to me like 3 different ways.
Yeah,
and I'm not going to get that from you.
Exactly.
So, yeah.
And so I kind of feel like, what is education? Like it used to be guides, it used to be lectures, it used to be this thing, but now, I feel like now more I'm explaining things to agents and maybe I'm coming up with skills where like, basically skill is just a way to instruct the agent how to teach the thing. So maybe I could have a skill for MicroGPT of the progression I imagine the agent should take you through if you're interested in understanding the code base. And it's just like hints to the model to like, first start off with this and then with that. And so I could just script the curriculum a little bit as a skill. So I don't feel like, I feel like there's going to be less of like explaining things directly to people. And it's going to be more of just like, does the agent get it? And if the agent gets it, they'll do the explanation. And we're not fully there yet because I still think I can probably explain things a little bit better than the agents, but I still feel like the models are improving so rapidly that I feel like it's a losing battle to some extent.
Okay. So I thought that whole commentary was so interesting and it lined up with a number of things that I've been reading and thinking about. This idea that instead of trying to teach people directly, we might be working on instructing models to make them more capable of teaching, because I can spend an hour and I can write a document with one explanation and one example and one something else. But if I spend that hour creating enough context for the model to understand what I'm talking about and be able to answer questions correctly and accurately, now the model can create an infinite number of explanations, an infinite number of examples. It was just very interesting to me to hear someone who's not an educator, but whose passion, I mean, obviously he's technically very capable, quit his job at OpenAI just to dedicate himself to teaching people about these tools. And this is the conclusion that he has arrived at as well. So I want to zoom out for a second, and I promise I'm going to bring us back around to instructional design here in a moment. But what is it that happened that AI kind of started working all of a sudden, when after years and years and years, it had not been very successful? If you're familiar with the idea of a neural network, you may have heard of what's called the forward pass and the backward pass. The forward pass is when the input comes into the network and it propagates through the network and there's an output on the other side. The backward pass is actually where the mistakes that have been made at the output layer are propagated back up the network and corrections are made along the way, so that the next time a set of input comes through the network, the output will be more correct than it had been previously. Now, that's about as high a level of description, I think, as it's possible to give. But as you listen to those things, you might say, gosh, it sounds a lot like the forward pass is practice, where I'm giving the model some input and it's trying to generate. In the case of a large language model, I'm giving it several words and it's trying to tell me what it thinks the next word should be. So I'm giving it that practice. And then the backward pass is the feedback, where, given what the model generated as its prediction, I'm saying that was wrong in this specific way. And so let's update all the parameters back in the model so that the next time an input comes in, your next practice will be a little more successful. And the feedback that we'll get will be a little different, maybe a little finer, a little more nuanced. And we just go back and forth and back and forth. This is the way these models are trained, with inputs coming in, which is the model practicing, and then feedback back propagating up through the model. That's the training process. And you will find that since the introduction of ChatGPT, the majority of the advances in the capability of large language models are all attributable to innovations in feedback, in the way that we give feedback to the model, the way that it's structured, the amount that we're able to give, the speed with which we're able to give it. And I want to try to draw out a lesson or two here for us as we think about what we're going to be doing kind of as instructional designers going forward. With the original version of ChatGPT, after the model, so models are typically trained in two stages, right? There's a stage that they call pre-training, which is kind of like taking all your GEs. Like basically, the model learns how to predict what the next word should be, or technically they call it a token, what the next token should be, but it doesn't have any kind of behavior at all. It doesn't act like an assistant, or it doesn't act like a tutor. It just spews words one after another. So that's pre-training. And then after pre-training, there's a post-training step, or what they call a fine-tuning step. And originally, the way that fine-tuning worked was humans would be paid to write very high-quality responses to prompts. And then the LLM would be given the same prompt, and they would generate a response. And then the LLM's response would be compared to the human's response, and then the feedback would propagate back up the network in a way that would nudge the model to write responses that looked more like the exemplar responses that humans wrote. SFT is how things worked kind of at the time that ChatGPT kind of came into the popular imagination. Really great, but what do we see here again? We see right at the top of this, humans having to sit down and write things, just like we were talking about a minute ago, where we have to write all of the feedback ahead of time. So this was great, but it was not very scalable. And it didn't permit large-scale immediate feedback. Well, a little later, this new technique called reinforcement learning with human feedback became a more popular way of doing fine-tuning, and things really took off here, and with successive versions of this that came after. And the way that RLHF works is, instead of a human writing an exemplar, a model generates two different responses to a prompt, and a human just chooses which of those is better. And as you can imagine, choosing which of two responses is better is dramatically faster than writing an exemplar response yourself. And so humans could do a lot of this kind of work, looking at a lot of these pairs and selecting which one was higher quality according to whatever rubric they were working with. And then those pairs of scores, the scores paired, this was the preferred response and this was not the preferred response, are used to train a reward model. And the reward model learns to recognize what high quality responses look like and what lower quality responses look like. And then the reward model is hooked up to the LLM. So the LLM generates responses, the reward model assigns them a score, and then that feedback is propagated back up the network so that the LLM learns to produce a response that looks more like a higher scoring response. And you'll see that at this point, there is no human left in the loop anymore. We're able to fully automate that process, meaning that it can happen at scale and it can go really quickly. And that's why you saw advances in the capability of LLMs advance more dramatically once RLHF became a thing. And then there's reinforcement learning with verifiable rewards and a number of innovations kind of after this. But the primary reason that LLMs got smarter and more capable is because we were able to provide them with better feedback more quickly. Okay, so I think I just said these things, right? Choosing the better of true responses is faster than writing the exemplar. Once the reward model exists, the human is taken out of the loop, and then that gives you scalable, immediate feedback that also embeds or encodes human preferences. I meant to say at the beginning, too, that if you're interested in the slides, on the final slide, there's a QR code and a short link that you can use to grab the slides, which are openly licensed, CC BY. Okay, so we're starting kind of the turn back toward instructional design now. We want to get there by talking a little bit about the path to either artificial general intelligence or artificial superintelligence, whichever of those terms you happen to prefer. Before we can get to significantly more capable AI, we need dramatic improvements in quality. AIs are still stupid in a number of ways. And before those kind of dramatic improvements in quality can happen, they need trillions and trillions of practice feedback cycles. And obviously, there's no way to do that with a human in the loop. So the path to AGI or ASI is, as people have described it, AIs training AIs, like we just saw a moment ago. If we can create reward models, or we can create ways for the AI to score its own work so that it can, or a separate model can score the work of the first model so that that can all happen very quickly and at scale, then progress can continue to advance. Now, I want to show you one more interesting piece of work by Andre here, something that he calls auto research. And we'll just take a look at this. Auto research is a little project he has going with his micro GPT, and let me bigify this a little bit. Let's see, the description. Well, the link is here. You can look through the description, but the idea basically is that he wrote a piece of software that interacts with his language model. And this is the number of errors that the language model is making over time. You can see it's kind of going down. But he set up an experiment where this auto research program kind of wakes up, it grabs a copy of the model, it hypothesizes a potential way to improve the training process, and then it gets 5 minutes to try to train the model using that updated version of the training process. At the end of the 5 minutes, if the model is more accurate, in other words, if the error has gone down, then it keeps that change that it made, and then it repeats the process. If that change did not decrease the error or increase the accuracy of the model, then it throws that change away and it starts again. But he's told stories about, I set this up to run before I go to bed, I hit run, and I wake up in the morning and 60 or 70 experiments have been run. And slowly you just see the error. There are big spans where there's no change because the things that the model tried didn't improve the accuracy. But while he was sleeping, the model was discovering ways to improve its own accuracy by running these experiments kind of in a loop, this automated experiment loop. So let's come all the way back to instructional design. Now, what on earth does any of what I've been talking about have to do with us? I think there are some really inspirational models for us in what's been happening with generative AI in the way that they've been pursuing innovations in feedback. And for us, I think it's interesting to ask the question, what kind of innovations in feedback would be necessary for us to, depending on which you want to do, either automate or optimize the instructional design process? And now notice I'm not asking about automating or optimizing instruction. That's a different question. I'm talking about automating or optimizing the design of the instructional artifacts or materials or process that are going to be used by the learner in order to learn. So that's different from trying to automate or optimize the learning experience itself, but maybe we can try to have our cake and eat it too here. So for the last couple of minutes of what I've prepared, let's look at 2 questions. The first is, can we design a prompt that will facilitate experiences that can result in meaningful student learning? So a student takes my prompt, copies it, pastes it into the model, ChatGPT or Gemini or Claude or whatever, they hit enter, and then it just starts asking them questions and taking them through some kind of guided learning experience. Can we design a prompt that will facilitate that kind of experience resulting in meaningful student learning? That's question 1. But maybe a higher level question, or kind of a meta question, is can we design a system for optimizing that prompt so that that prompt will result in the most effective instruction that it can? How can we automate and optimize the design of the prompt if you think now that the prompt is kind of the core instructional material that you're designing? So I want to linger on this second question for a moment and share with you some things that I've been reading and just running into in all kinds of places lately. First, this fellow called Nate Jones, who is a terrific YouTuber on everything related to AI, has been railing for a while about what he believes to be the most important skill available to us now. And now the genie is kind of my metaphor here, but Nate would argue, and I think there's a lot to be said for his argument, that when you can essentially ask for anything and you're likely to get what you ask for, then the most important skill becomes being able to clearly articulate your intent. If you can have clarity of thought about what it is that you actually want, and you can express that in clear prose, so you can communicate it to the model, then good things are going to happen. As these models get more and more capable, we're able to ask them to do more and more useful and valuable things for us. But so in the context of our questions we're trying to answer here, clearly articulating our intent means being able to say with real precision, what exactly does good teaching look like? And I'm not saying that there's only one answer to this question. Obviously, there are multiple answers to this question, but you have to have an answer to this question. You have to have a hypothesis about what exactly good teaching looks like so that you can articulate it clearly in writing. Because, I mean, and one way to think about it is think about a brand new person who's just finished their undergrad in their discipline. So maybe they are an economics major and you're going to put them in front, they're a brand new grad student in economics and you're about to put them in front of an Econ 101 course. What can you describe, explain, detail? Can you give them enough information to help them enact evidence-based teaching practices in a way that are going to result in good student learning there? That's kind of the way to think about it, right? Is trying to write instructions for a generally intelligent person, but someone who doesn't know the domain that you're asking them to act in. So once you've written that down clearly, mission accomplished, right? I would have gotten the picture of the mission accomplished banner here, but I decided to skip that. Obviously, clearly stating our pedagogical intent isn't enough. We have to verify that the model's enacting our pedagogy with a high degree of fidelity. Well, enacting pedagogy requires both a teacher and a learner. If the LLM is being the teacher, right, because we've written this prompt that's going to cause it to act as the teacher, then how can we have it enacting pedagogy without reintroducing a human into the loop and slowing this optimization process down? Some of you may know that I have a book coming out next month. I say a book, it's really just a website. It's all open access, all CC BY licensed. I don't feel like I'm inappropriately shilling anything here because there's nothing for you to buy. There's just going to be a book website with a bunch of online chapters in it called the Pedagogical Prompt Book. And one of the chapters in the prompt book features some really terrific work by this group of authors down here at the bottom on creating synthetic learners. So answering our question here, if the LLM is acting as the teacher, who can the LLM be teaching in order to be running this optimization loop? If we don't want to plug a human back into the loop, who's going to be the student? Their answer is these synthetic learners. And so they develop these kind of 4 dimensions of characteristics that these personas might have, right? So they have some level of experience, some degree of prior knowledge, they have some level of motivation, some level of confidence, and some level of receptiveness. And these tables are in the chapter, which you'll be able to see here in just a couple of weeks. But in this work, they present these personas. So, Amara has kind of low experience, medium motivation, medium confidence, medium receptiveness. And the archetype here is they're just kind of a baseline novice. And here this person is the kind of anxious striver or the overconfident coaster, the novice who thinks they know it all, right? Or the expert who's actually kind of hesitant because they suffer from imposter syndrome. Or just the defeated learner who has learned helplessness, just low all the way across. In the chapter, they talk about how they take these personas, feed them into language models, and get the model to act as if they were, having adopted one of these personas. And they do some really nice work there. You're going to love this chapter so much. It's one of several that are just really great. But if we can state our pedagogical intent clearly and create a prompt that we think will get the model to enact the pedagogy with high fidelity, and then that pedagogy, the model can practice teaching like these synthetic learners, then that's great. But what do we do at the end of that process? Well, there's an approach called LLM as judge. And we saw an example of it a minute ago with RLHF, where one LLM is acting as a judge. It's judging the work being done by another LLM. So in this case, the question we're trying to answer, we might have one LLM that is enacting the prompt. They're being the instructor. You've got a second LLM who's adopted the synthetic learner persona, and these two are interacting with each other. And through that interaction, they're generating a transcript of the conversation that they have. And at the end of that process, a third LLM then can use a rubric to score the instructor's performance in terms of their fidelity of enactment of the pedagogy. Now, there's been some very interesting work done at Google, and which is also referenced and extended by some of the chapters in the prompt book, on making LLMs more reliable users of rubrics. So here's an example on the left of and this is a screenshot. This and the next are from the Google article, of a conversation between a user and a model. And the way that a rubric typically works is you have some statement like this section references all the relevant data, and you say, well, none of it's referenced, or some of it is, or half of it is, or most of it. But you have to make this kind of distinction, which human beings are typically capable of making if the rubric is done really well, but iterator reliability is still something that is hard enough to achieve that we go out of our way to measure it. But what the Google folks show is that if you take these kind of Likert scale, and yes, Likert, not Likert, if you take these Likert scale measures and convert them from kind of choosing a value along a scale and convert them into either Boolean, yes or no, did it happen or did it not happen in the conversation questions, then you can actually get much higher reliability using a rubric that has these yes or no questions than you can using a rubric that has these sum of, half of, most of, like we're used to writing for each other. Now, they do make the point in the article that when you take all, you might have 7 or 8 of these in a typical rubric, and by the time you explode them out into all the Booleans they could possibly become, it becomes a huge amount of scoring to do, which is fine for a model, but when you want to calculate that iterator reliability at the beginning of the process, you still need a human to sit down and mark it to compare scores between the model's work and the human's work. And it's prohibitive. These are just prohibitively long to do very many of them. So they kind of develop and explain this process that they call adaptive precise Boolean, where they take this whole list of Booleans that are generated by exploding out everything in the original rubric, and they pull out just the ones that are most important instead of pulling out all of them. And then what they show, I'm going the wrong direction. What they show in the paper is that the iterator reliability is just between humans, whether they're non-experts or experts, the iterator reliability between the people and the ratings done by the machine using this Boolean approach is so much higher than it is using a typical Likert scale kind of rubric. So you get these really high levels of iterator reliability. And then when you look at time on task, using this kind of adaptive approach where you only take the most important of the Booleans, by 30, 40%. Or no, more than that. Sorry, it's only about 30 or 40% of the amount of time necessary for a human to score. So there's some really interesting work going on with the rubrics as well. And when we take all of this and we put it together, we have all the ingredients that we need, and particularly the innovations and feedback that we need in order to run something that looks like an auto research style loop over the prompt, which is going to enact our pedagogical intent. Learners are going to engage with that. It can be scored by this LLM as judge using these Boolean style rubrics. And then there's no human in that loop. That cycle can happen very rapidly. And then we can just keep trying to increase the score of that prompt in terms of its fidelity of enactment to some arbitrary threshold, or run it for some period of time, however you want to approach that. And then at the end of the process, you have this refined and optimized prompt that now can be used by students to support their learning. And of course, we'd want to do similar kinds of study with the transcripts generated by students using the prompt. But for the first time that I'm aware of, we have this meaningful pathway now, and this real opportunity to fully automate and optimize not the learning side of things, but the instructional design side of things by just putting a couple of these pieces together. It's very much like train the trainer, right? So why do we train the trainer? When you do train the trainer kinds of things, the reason you do them is because you, the trainer, can't get out and teach all the people that need to be taught. So you train trainers to go out and do that for you. And it's almost like a next generation train the trainer kind of way of thinking about it, right? In the past, our primary audience as instructional designers have been the human learners. We were building artifacts for them to engage with and learn. But I think that going forward, I think in a lot of cases, the primary audience for our work will be the models. And if we can provide the models with the right context and with the right instructions and optimize them in this way that I've been describing, they can go on and teach the learners with infinite examples, infinite explanations in Spanish or Chinese or Japanese or whatever language it is that they need it in. This idea of kind of training the trainer and empowering this to go out at a different kind of scale than one person can accomplish is just really super exciting to me. So postlude, I just want to say a word about cost and control. I know one of the concerns that people have about using AI in education is about expanding the digital divide. So suppose that these kind of optimized experiences really did dramatically improve student learning. Well, tokens cost money. And if that's the case, do we run the risk of wealthy students having even better opportunities and learning even more, and our students who can't afford those things kind of being stuck behind? So how do we make this affordable? I've got a link here in the slide. I'm not going to linger on it, but there are a number of examples of late of people taking smaller open source language models and doing that post training that we talked about, training them to not be generalists that are great at anything, but to just do one task really, really well. And it turns out that with a small, freely available, openly licensed, open source model that you fine-tune to perform one specific task, when you're only measuring it on that task, that model can beat all the other frontier models in the world. And this is an example of that. And again, the link is in the slide notes. So as we think about what this all looks like going forward, and here's my one little tie back into open. When these models are open source, you can download them and run them on your own laptop. And when you can run them on your own laptop, that improves privacy, it improves security, it decreases all the energy consumption concerns that people have about massive data centers because you're just running something on your laptop. Because it's running offline, it doesn't need a network connection, it's just running on your computer. We can run these models places where there's either low bandwidth, shaky, sketchy access to bandwidth in terms of reliability, or no internet connectivity at all. And when you run these models locally on your own computer, you're not paying per token like you do when you're using Claude or using something else. You get to use them for free. So I think there's an important role for open to play here in terms of equity and access and affordability as well. So, okay, I think we managed to save a couple of minutes for conversation. There's the short link and there's the QR code. There's my email address. And I hope that there's something in there that provoked some kind of response in you that you thought was interesting. So let me pull up the chat. Or unless, Charlotte, if you've kind of been paying attention along the way and
I do, and I have been. I'm going to, if it's okay, I'm going to repost a question that was asked earlier on in the chat from Rachel.
Please.
And she said, this is a bit delayed and now even more delayed. I'm not sure that our energy is best invested in teaching agents rather than humans. a lot depends on the accuracy of the agent, to say nothing of motivation, etc. I read the following this morning, so it's on my mind, and it talks about the exhaustion problem when generative AI goes. So what do you think about that?
Well, I'm certainly exhausted by AI, but I'm exhausted by it for completely different reasons, right? I lay in bed at night thinking about all the things that I'm now capable of doing that I wasn't capable of doing 3 years ago. And the fact that I'm not doing nearly as many of them as I could be doing. And I find that to be exhausting because I just feel like I'm leaving all kinds of growth and engagement and other kinds of opportunities for my students on the table because I'm not getting around to getting all of them done. The question about where our energy is best spent, I would come back to the train the trainer metaphor. Some people don't want to train the trainer. They want to do every training themselves and make sure that they're the ones interacting directly with the learners. But at some point, if you're going to achieve any kind of scale, and scale isn't righteous or virtuous in and of itself. Scale just means that more people are having the opportunity to learn. If we're going to achieve any kind of scale, it seems like we need some kind of train the trainer sort of model. And you can train humans, obviously, to go be the other trainer, because that's the way we've done it for a long time. But now there is this opportunity to train models as the trainer. And I don't think we've explored it hardly at all yet. And I think there's a lot of interesting, exciting work to be done here. But ultimately, Rachel, it'll be an empirical question, right? We'll need to try it and see what happens. And then then it won't just be me having an opinion about something. We'll be able to look at some results and talk about them in a more meaningful way.
Yeah, absolutely. And I had a question that kind of popped up as we were going through it. And just honestly, your opinion, looking at it, given about, these ASIs, I asked, do you think these ASIs will wear a cape because they're super? How do you really imagine in 3 years learning experiences will look in the future as ASIs become a reality?
This is going to sound super offensive, and so I'm going to apologize ahead of time. But faculty are so slow to adopt any innovation at all at scale, right? Now, you can always, on every campus, you can find 5 or 10% of the faculty who are down for anything. They built custom islands in Second Life back in the day, and right, they'll do anything at all. You can always find those people. But if you look at something like courseware, which has been available for 15 or maybe 20 years now, things like My Math Lab or things like Alex that do provide immediate feedback, infinite practice. Tools like that still aren't even adopted by half of faculty. Adoption rates for those are somewhere between 30 and 40% nationwide. And that is an innovation with clear benefits and opportunities in terms of amount of practice, speed of feedback. 20-ish years old, and not even half of faculty are using them. And I just mean in the classes where they could be used, right? So all these things are possible now. They might be a little hard now. They'll be very easy 12 months from now because we'll use AI. I'm going to use AI to build the harness that I need to do all these things I've been talking about today. But can we get faculty to adopt them or not? And if we can't get faculty to adopt them, then the tree falls in the forest and nobody hears it. And it doesn't matter, except that will our students keep coming here if there's something so obviously superior and we refuse to engage with it? Like that's the real concern for me. But I think in terms of the availability of tools and their capability to explain things to us and give us new examples and give us plenty of feedback and the opportunity to explore our curiosity or to ask the question we are too embarrassed to ask in class or whatever it might be, that's just going to get better and better. And the question is, will faculty stick their heads deeper and deeper into the sand, or will something else happen? And I am a faculty. I am faculty, right? So I'm not just talking about you people, I'm talking about us people, right? I want to make sure first person inclusive there.
And again, I think it's always true that adoption is going to be widely dependent on the individual. And just one more question really quick from Carolyn Sycama.
Yeah.
She asked, for the synthetic learner scenarios, do you think you would first ask users to rate themselves in some capacity as a learner before interacting with the agent, so the agent can provide an appropriate response to the student based on their learner situation?
No, 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 no. You wouldn't ever ask the learner to identify themselves in any way like that. You want the prompt to be able to respond to all kinds of learners. So you need a wide range of personas. And then, but the model never like the model that's doing the teaching doesn't have access to which persona it's talking to at the time. It's just talking to another quirky learner who seems unmotivated or whatever. So when a real student is working with the prompt, they're never being asked to identify their level of motivation or something like that. The model is just having a conversation with them. But if we've been able to optimize that prompt over enough conversations with a wide enough range of synthetic learners, then kind of no matter where you fall along that spectrum, the model ought to be able to have an effective conversation with you. That's the idea.
Excellent. Well, thank you so much, David. I think that you gave everybody a really huge amount of information to think about. Thank you so much for the slides. I know that several people are already in those slides. I can see them digging through already. And I think that we're all going to be checking out your book. When did you say it was going to be released?
About halfway through April.
Okay, halfway through April.
But yeah, the chapters are all finalized. I'm just trying to get them moved into the online publishing platform now. So as soon as that's done, it's at thepromptbook.org is the URL. I'll have announcements on LinkedIn and things like that when it's available. I'll make a lot of noise. But man, there's some really great work being done on a bunch of these problems, and just putting these Lego pieces together. There are some really cool things to assemble going forward.
So exciting. Well, thank you so much. We truly cannot wait. And thank you again. It was truly a pleasure to have you here at the TOPkit workshop, David. Thank you so much for joining us.
Thanks for the invitation. It was fun.
Yay.
If you have questions, please do send me an email. Love to talk about this stuff.
And believe him, he does respond to emails, everybody. So please, please, please don't hesitate. Sorry for giving you an out there, David.
Good, thanks.
All right, I'm going to hand it over to Sue.
Thanks. Thank you so much, Charlotte. Yes, as you can see, I put up a slide to just let you know that we have.
This environment was already in use by some faculty, which made it a practical place to start, and it gave us a consistent supported space where we could focus on improving the workflow itself rather than adding new tools or creating additional overhead. And importantly, the tools in this environment are continuing to improve in terms of accessibility. Posit comes out all the time with new accessibility updates, supporting both PDF, HTML. So it really is, it felt like a really good place to start with this work. So it means that the workflow can stay the same, but the outputs can often improve over time. So once we have the environment identified, at a high level, the workflow is pretty similar to your normal content creation workflow, where it's not really a specific tool. Those can vary, but the workflow remains consistent, where we create content using our tools in an accessible way and export them as accessible formats. We check those, we validate the accessibility, and then we share them in a way on platforms that support the accessibility as well. So what does this look like in practice? I feel like that's what you all came here for. So we will go into RStudio. Now this is a hosted environment for us, but I will say that this is possible on a local installation of RStudio, and not RStudio Pro, but RStudio. You just have to manage all of your permissions and manage your libraries and things. But it is most STEM faculty are familiar with this or other programs that function like it. So let's see. It's probably a little bit small for folks, so we're gonna move this over a little bit and make it a little bit bigger. So this is a QMD file. So we're using Quarto to write the document within RStudio. And so this is really combines both narrative, math, and code in a single source. And so we have everything kind of lives in the same space. And instead of separating these, we can author them. And I'll scroll down a little bit so you can kind of see some math examples where we can write inline math and algebra. And we're using LaTeX, little snippets of LaTeX within the for inline math and for larger larger blocks. So this is especially useful in statistics. So you can also, I hate to scroll too much, but I made a lot of examples. But it's also really helpful for statistics because you can create code sections that you can actually render. So you can run the code, you can teach students how to write the code, and then they can actually see what happens when you run the code itself. So those are really, so it's really helpful to kind of see everything within context. This is web-based, structured content that can be shared directly with students instead of static documents. It can be updated, reused, and delivered in platforms like Canvas. And the math is not flattened. So we can render that and I'll switch it over to what comes out. And you have different options of what kind of products can be created from the QMD file. You can create presentations like the one that I'm using to present today. And you can create documents, you can create web pages, HTML. So it provides a little more interactive experience than just say a Word document or